Welcome to Train Signal. You're watching Virtual Network Management and Implementation. So let's talk a little bit about virtual networking. Some of this will be a review. Again, kind of harking back to the VCP level knowledge for the VCAP as an initial foundation. But most VMware administrators are familiar with some facets of virtual networking. vSwitches, port groups, physical NICs, and virtual NICs. I call those PNICs and VNICs. And seeing more and more adoption of the vSphere distributed switch. Similar concepts, but more advanced features. And anytime we're talking about the VCAP, we want to lean toward those advanced features because I think that's what you're probably going to see most of. They definitely hit on the VDS within the blueprint guide, so pay attention to that. Here's a quick kind of overview of the vSwitch architecture, just as a review. Remember, we have a VM with virtual NICs, VNICs in those, connected to port groups, and port groups live within vSwitches. So we have the construct of a vSwitch with port groups, and then within a vSwitch we have physical NICs or PNICs that act as uplinks, and we can set those as active or standby on a per port group basis. So remember relationships: VNICs connect port groups are in a vSwitch, and a vSwitch has physical uplink NICs. Compare that with a little bit to a VDS. So a VDS, we kind of have this all-encompassing switch. Now, you can have multiple VDSs. A vSphere host can belong to 3 or 4 vSphere distributed switches if it wants to, but often we just see one. But the point is that we still have this switch, we still have port groups, we still have VNICs within the VM, and physical NICs acting as uplinks within the distributed switch. We only have one set of uplinks. So every VDS only gets one what we call uplink group. If I have 3 NICs like I do here, those all 3 are in a single uplink group. We will talk about how we can kind of tweak that so that maybe if we have a backup network that we wanted to dedicate to this NIC here, we can do that. We can say, hey, for these two, for server, network, and management, these 2 guys are active and this guy is unused, but for backup network, he's active and these 2 are unused, and we'll talk about that later. But keep in mind, every distributed switch has a single uplink group. Now let's talk a little bit about how to get pure performance. This is kind of an aside, but it's something that's hit on in the blueprint, both in the networking section as well in the storage, and that is VM Direct Path. We've hit on this before in an earlier lesson on storage, so I'm just going to kind of refresh your memory but not go through the lab again. Now remember, the vSphere hypervisor has very low overhead, like low single digits. But if you don't want any overhead for network I/O, you can pass a physical NIC straight through to a VM. That's called VM Direct Path. It works for HBAs and other devices as well, but normally we see it for NICs and HBAs. As we saw earlier, just keep in mind of a few things that, like, you have to dedicate the hardware, obviously, and it breaks things like vMotion and DRS. So make sure it's worth it. It's fairly rare that we see this used, but it does happen, especially on something maybe that's really sensitive to latency, and you want to make sure something has direct access to hardware. Again, the requirements, kind of the same as before. System must support Intel VTD or AMD IOMMU. You have to set a full memory reservation for the VM. That's just one of those gotchas. If it's an 8 gig VM, you got to set a reservation of 8 gig, which isn't great, but it is what it is. Again, it breaks vMotion except Cisco UCS. So Cisco UCS is a platform that I really like for several reasons, and one of the reasons is this: there is a way that you can do VM Direct Path. It's called pass-through switching with UCS, but basically UCS has this concept of splitting up its physical NIC ports in the blades to a bunch of virtual NIC ports that are still hardware PCIe devices, and those get passed through to the VMs. And due to the architecture of UCS, you actually can vMotion the VM even when doing VM Direct Path with a NIC. So it's an interesting concept. We do a lot of UCS. Very few people do this, but it is an option. And then the guest OS must support the pass-through hardware. So as we saw, again in the lab earlier, if I pass through an Intel 1000 NIC, the Windows system or whatever that receives it has to have a driver for that. It's not abstracted. It doesn't use VMXNet. It actually has to have a driver for that hardware. And here's a diagram. Again, fairly simple. We have a NIC for a backup network dedicated for whatever reason we thought this may be necessary to a VM, and it just bypasses the vSwitch port groups and all that stuff completely outside of the hypervisor. So what is the vSphere distributed switch? Well, we kind of already talked about it a little bit, but let's talk about what it is, what it does, and why you might want to use it. It is the second vSwitch included with vSphere. The other one is just the standard vSwitch. This one is called the VDS. They changed it a while back, so the capital V is actually correct. And it requires Enterprise Plus licensing. So, not everybody gets to take advantage of it, but you'll find that VMware is pushing a lot of these new cool features up to Enterprise Plus. It allows for easier administration for medium and larger environments. You add a port group in vCenter in the switch, all hosts automatically see it. So that's a great advantage. You don't have to make sure you name everything the same and set it the same across all your hosts. But it's not just for larger environments. I get that a lot. People think, I don't need it. I've only got, 12, 14, 16, or even less hosts. Why do I care? There's a lot of cool advanced features that you may want to take advantage of. So it does things that the standard vSwitch can't. Network I/O control. So we can now take network traffic and split it for special kind of traffic like VM, NFS, iSCSI, vMotion, fault tolerance, and management, and even VM level at a port group level, so certain port groups but not others. We can dictate priority, shares, and things like that. So we can say, hey, vMotion, you have low priority. VM traffic, you have medium. NFS, you have high priority, and pick and choose how we want it. We can even say production, you get 100 shares, and dev, you only get 30 shares. Therefore, under contention, production gets what it needs. Port mirroring, span and ER span, and this has gotten even better in 5.1. I remember the VCAP currently is on 5.0, but this is getting better even with 5.1. We can now do ER span. Basically, this allows us to sniff traffic across a switch, and with ER span, we can now even encapsulate traffic and send it to another VM to an IP address. On 5.0, when you do port mirroring, the two VMs, the destination and the source, have to be on the same host. With 5.1, we can actually split them. So again, it's very useful for that. Can't do that with the standard vSwitch. NetFlow support. If you've never seen NetFlow, it's very interesting. What you can do is you have a NetFlow collector. That collector is, there's a lot of collectors. There's free collectors. SolarWinds has a collector. There's a bunch out there. And what you do is you point your switches to it, whether it's this switch or a physical Cisco switch or Juniper switch, and it will give you statistics on what it sees. Traffic, protocols, conversations, all sorts of stuff, and you get great reports and information out of it. The VDS supports sending information about your virtual environment to a NetFlow collector, whereas the standard switch does not. Private VLANs. We'll hit this in a later lesson, but the idea is you could have like a DMZ where we have a group of servers that all talk to a firewall or an internal router all on the same layer 3 IP subnet but can't talk to each other. It's like layer 2 filtering. It's filtering at layer 2 at the MAC address level, and it almost acts like VLANs within a VLAN, and we'll talk about that more later. Ingress and egress traffic shaping. So you can set, the amount of traffic and bursting going into and out of the switch, whereas with the vSwitch it's only one direction. And then SNMP support. So we can actually do SNMP against the VDS. This is actually fairly new, but it is an option now for being able to set SNMP support. Pretty handy for things like NetFlow. VDS architecture has two main components. You have the management or control plane, which is integrated into vCenter. I spell this out because you have other third-party switches like the Cisco Nexus 1000V, where its management plane is a separate piece of software. The VDS, it's built into vCenter. It's nothing separate that you have to manage, update, or configure. And then you have the I/O or data plane, which is built into vSphere. So it's kind of made up of these hidden vSwitches. You'll never see them. Obviously, they're hidden. But it's just kind of that's how it works behind the scenes. Again, no other software to install or manage. It's all built right in. Control plane is responsible for all configuration and management, and the I/O plane handles data flow. What I want you to know about this is they are separate. You can shut vCenter down and your data, your VMs still talk to the network just fine. There may be some gotchas on booting VMs, but for the most part, everything continues to work with the control plane down. No extra modules or components, unlike, say, the Nexus 1000V from Cisco, which has what's called the VSM Virtual Supervisor module and the VEM's Virtual Ethernet modules that get installed on each vSphere host. What's required? I already mentioned this, but Enterprise Plus licensing is required. They're pushing all the cool stuff to Enterprise Plus, but there's nothing else that's really required. There's no special hardware. You don't have to have any certain switches. You don't have to have any special network cards, nothing like that. Whatever works on the hardware compatibility list and works with the standard vSwitch works just fine with the VDS. Lab time. So let's go ahead and I'm going to show you how to deploy a new VDS, perform basic configuration, and go ahead and migrate a host, a VM kernel, and 1 or 2 VMs to the VDS. So this will be the basic config. We will do a more advanced config with some of the other options in a little bit in another lab, but let's go ahead and get the VDS stood up. Okay, here we are back in the lab. Now, the first thing that we want to do is go to Inventory Networking. And here we have my data center. So that's a good point, actually. Distributed switch is kind of a data center concept. So you can have multiple clusters all using the same distributed switch. It is not at a cluster boundary. It is actually at the data center boundary. But anyway, you want to right click and do a new vSphere distributed switch. So then it's going to ask you some questions. Now I'm on vSphere 5.1. The VCAP is currently on 5.0, but it doesn't really matter. Most everything is the same, but actually for this I'll do 5.0. That way you don't see anything that you wouldn't normally have access to. It's going to ask you what version. So if you, for some reason, have older hosts or hosts that you may add that are an older version, you need to make sure and set the right switch version. So if I have a 5.0 cluster, but I may add a 4.1 host or have a 4.1 host, the latest I can go is 4.1. Now, if you set this as 4.1, you can come back anytime and non-disruptively roll the version forward. You can always go forward, you can't go back. But since all my hosts are at least 5.1, I'll go ahead and set it to a 5.0 level. Then it says give me the name. This is the name of the switch, so I'll just call it NashLab VDS. And then it says the number of uplink ports. So this is the maximum number of physical NICs that may come out of one of your vSphere hosts. So the default is 4. You can bump it to 8 or 32 or something. The idea is just set it to a reasonable number. If all your hosts have a maximum of 8, set it to 8. If one day you add another dual port NIC to all of them, you can come in and again non-disruptively set it to 10. It's just for your own benefit, so I'll leave that at 4. Then it says, hey, do you want to go ahead and roll some hosts over? So you can do this now, or you can do it later. Let me just go ahead and do some stuff now. So I'll do one off of Optimus here. I'm going to say, yeah, I'm going to go ahead and move a host over. When you add a host to the distributed switch, you normally tell it which physical NICs you want to use as an uplink. So you don't have to choose them all now, but since VMNIC 3 for me is free, I'm going to go ahead and choose that one. So I'll say next. Then it says, hey, do you want me to go ahead and create a port group for you? Now, this is helpful, but not really helpful because you don't get to pick the name. You don't get to tell it what VLAN it's on. You don't get to do anything. So I normally say no. And we'll say finish. And it'll go and you'll see it kick off the jobs and it'll create the distributed switch. So at this point, it has gone ahead, created the switch, and it creates what we call our first uplink group. Now remember I said each switch, each distributed switch only has one uplink group. So let's look at that. And here's the uplink group. You can give it a different name if you feel the need. Here's all the policies. There's not a whole lot you can set here, but the one thing you do set is your VLAN trunking range. So by default, it's going to say, hey, I'll trunk any VLANs you want me to, 0 through 4094. Now, if you're a good little network admin, and most of us aren't, you will set it, and so you tell it to only trunk the VLANs you actually need. Most people set it to be all. But if you're only going to trunk 5 VLANs, you may specify them here like 1, 5, 6, 7, 8, 9. Actually, that's not a great example because I could do 1, 5, -9. But you get the idea. And so it's completely up to you as to how you want to do it. That was it. And so just set it and make sure it's set to match on your physical switch ports. Other than that, there's really nothing else that you can set here except maybe override your port policies, but most people don't change those defaults. Then you've got the main switch. So there are some things that we can do here. So let me manage this. A couple of things. You can change the name of the switch at any time. This is something I highly recommend people do. So again, we had 4 uplink ports. Here they are named DV uplink 1, 2, 3, and 4. Now, why would you want to name these? Well, I tell people to name them because DV uplink 1, 2, 3, 4 means nothing to me. What if you have servers with 2 onboard NICs and 2, add-on NICs? Then I would name these onboard 1, onboard 2, PCIe 1, PCIe 2, something like that. And then when you add hosts, you can go ahead and say, okay, VMNIC 1 is onboard 1, VMNIC 2 is onboard 2, etc., and match them up. That way, when we start making some changes to those NICs and maybe say, okay, we want this port group to use 1 onboard and 1 add-on, we actually know which ones they are, and they're not just called DV uplink 1 through 4. We have the advanced. If you want to set jumbo frames, this is where you do it. So you'd come in here and set this to 9,000. Again, make sure your physical switch is prepared for that. Let's see, discovery protocol. So the standard switch only does Cisco's discovery protocol, CDP. What if you have non-Cisco switches like HP switches? They don't do CDP. They do what's called LLDP, Link Layer Discovery Protocol. It's like a standard version of CDP. So you want to make sure and choose that. Remember, Cisco, CDP, non-Cisco, LLDP. So you'd enable it, and then most of the time I'm going to do both. This way, if you just set it for listen, you'll get physical switch information on the properties of your NICs. I'll show you, and which is nice, but it's, it pulls it this way, but if I'm on my switch and want to see which vSphere NIC is connected, I can't. So to do that, I need to set it to both. I'll set it back to Cisco because that's what I have. You can set your admin name and details if you feel the need, but Network adapters is just going to give you a list of the hosts and the NICs that we've rolled over as uplinks. Private VLAN, we have a whole lesson on. NetFlow. So we talked about NetFlow and NetFlow collectors. I'm not going to do a demo of NetFlow here. The beauty of Train Signal and their subscription is that I have a course called Advanced vSphere Networking. It's an entire course on the distributed switch and all of its functions and all of its advanced features in very much detail, as well as physical connectivity for your switches. I do a demo there, so if you want to see that, you may want to jump over to some of those lessons. But for the VCAP, I don't expect them to make you deal with an actual collector. They do want you to know how to do configuration, so I'll show you that. It's very easy to do NetFlow config. All you do is you give it the IP of the collector, the port. Port is set to 0. The reason being there's no standard port for NetFlow collectors. It can be 52, it could be 1018, it could be 9043. You don't know. That's got to come from your collector information. So set the IP, set the port, and over here we have what's called a VDS IP address. So anytime you're doing anything with a NetFlow collector, it's going to say where it got the information from. So where did it get the information from? What IP address? Well, it could be anything. It could be any of the vSphere hosts. So what you put here is an IP address that you want to show up in the NetFlow collector. So when it sends it information, it says, hey, this came from IP whatever. A lot of times I just put the IP of the vCenter server here because that's where it came from. But if you want to dedicate one so you know what it is, you can do that. So just put the IP that you want it to show up here. Then you could do timeouts, export timeouts, and sampling rates. Normally this stuff will be given to you by your NetFlow collector information, but it's just setting your sampling rates and things like that. So if you want to do something like, if you want to sample every 10th packet, you just put 10. If you want every other packet, 2. If you want every packet, 0. And you can say, hey, I want you to process internal flows only, things inside the switch that don't go out. you can check that box. But that's basically it. Once you hit OK, you should go to your collector, wait a couple minutes, and start seeing data come into it. Oh, real quick before I forget. Then what you need to do is, let me create a port group real quick or I'm going to forget to do this. So we'll just take the defaults, say finish. Manage the port group. Look under policies. NetFlow status. So you have to go to each of your port groups and tell it if you want it to gather NetFlow information on a port group by port group basis. So once you configure it, you need to enable it. Then wait on your collector and you should start seeing information. Sorry for jumping around, but I want to make sure I mention that because if you don't do that, it will not work. And then port mirroring. Port mirroring is just spanning. This is 5.0, so we can't do things like ER span. And I'll tell you in 5.1 vSphere with the new web interface, this interface is much better. It's much more of a wizard. It's much more simple, and it lays it out better. But basically, you set up a session name here, and you can create sessions now and enable them or disable them on the fly. So if you have an app that you sometimes need to capture traffic from on kind of a regular basis, you don't have to go through this and configure it every time. You create session once and enable and disable as you need it. And so you just click add, and you give it a name, demo span. And then you can say things like, let's see, allow normal I/O on the destination port. So if I send traffic to another port, do I want that port, that VM's NIC to also handle normal I/O in and out? Normally I do, but you may have a VM NIC set up so its only purpose is to receive span information, and you may not want it to do I/O. I usually do. You can encapsulate the captured traffic in another VLAN if you want to. And you can even have it preserve the original VLAN inside the encapsulation. This is handy if you're sending the traffic somewhere else and it needs to be encapsulated in a separate VLAN. A lot of times you don't care what's actually in the packet. You just need the header to see who, from who, to whom, what protocol, things like that. So you may only care about like the first 60 bytes. If you want all the packet, you need to uncheck that box. Then you specify a source. So first you say ingress or egress or both traffic, in or out or both. And then you do a port ID. Now here's the fun part, right? It would be nice if you could pick a VM and say, hey, I want to grab traffic from my media VM, NIC1. But instead you have to have the port ID. And I'll show you where to get that in a minute, but you add that. Let me add one here. Say next. Then you set the destination type, and you've got two options. So the destination type can either be a port, which is another virtual switch port, another VM's port, basically, or you can say, nope, I want you to ship this out one of the physical NICs in the server. And what you may have on the other side of that physical NIC is a switch set up to capture traffic and forward it to, say, a span or a net probe or something like that. So you could say, nope, any traffic you capture, just shoot it up DV uplink 4, and call it good. Or again, you can set it to a specific port. So we'll say next. It tells you created it. You can go ahead and enable it if you want to. I'm going to leave it disabled. And there you go. So the place that you would normally get your port ID, if I had any VMs over here yet, you'd go to the VMs tab. And off here would be some port information. And you'd be able to, oh, I'm sorry, that's not correct. That just shows it. It's the ports tab. So we would have a list of VMs, and here's your port ID. So if I wanted to get it off my media machine and it was connected to this switch, I would scroll down until I found it, or easily search it up here in the box. You can search the name, all sorts of information, but find that machine and get the port number. So if I wanted to source it from that machine and it was port 8, that would be my source. If I had a Windows machine, say running the Wireshark, which is a free packet sniffer tool, and it was connected to port 17, that would be my destination for span. So it'd be source 8, destination 17. So you have to go manually look those up. So let's see. Next, we want to do a little bit of a migration here. So let's create a port group. Let's go ahead and right click and do a new port group. So this one, we'll call this one VM Network. I'll come back to some of my port information here later, but we're going to set it to set the VLAN and set VLAN to 5. Now you have a couple of options on VLAN. None, which is untagged. VLAN, which specifies a VLAN. Trunking, which says I'm just going to pass frames up to the VM without stripping the VLAN tags. So it's just going to pass them up and do what we call, host tagging. Then you need a driver in the guest that understands VLAN tags. Don't see that too often. Most people just tag it there. Or private VLANs, which again we'll talk about in another lesson. Next, and finish. So now we've got our switch basically set up, our basic configurations. We got one port group created. And now we can do things like migrate stuff. So if we want to, we can migrate virtual machines. There's a wizard here that I just clicked and exited, but it lets you walk through. So we can say, okay, migrate things from the existing VM network to the new VM network. You notice it puts the distributed switch name out to the side. Say next, and here's all the machines that we can migrate that currently live on Optimus. Megatron is not allowed to participate. Notice it says inaccessible because we haven't moved him to the switch yet. But if we wanted to, let's see my little media machine here. We could say yes, go ahead and migrate him over. Next. He's going to migrate him from the old to the new. We say next, and off he goes. So if you get in the exam and they tell you to migrate some VM networking from a regular switch to a distributed switch, don't go VM by VM. Use this wizard and do it in one shot. Again, time is of the essence. Use what you can. Then we can do things like, migrate VM kernel interfaces. So for that, we'll just go to hosts and clusters, go to Optimus, go to configuration, go to networking, and then go to distributed switch. Let me give us a little bit more room here. A little bit over, and then we can do things like manage virtual or manage physical. So let's say I wanted to move one of my other physical NICs into one of these uplinks. I would do manage physical, and then I could just come in here and say I want to add another NIC. You can choose an existing NIC, and it'll rip it out of this switch and put it in the distributed switch if you want. Or if you have unclaimed adapters, this is a 10 gig adapter that's not actually plugged in, you can choose that, say OK, and it'll add it as another physical uplink. If you want to manage virtual interfaces, mainly VM kernels, you do that here in the Manage Virtual Adapters. So click Add. Now, when you click Add, you have the option of a new one, so I can create a new VM kernel, or I can migrate an existing one. So let's migrate. And it says, which one do you want to migrate? Well, migrate FT network. And then you say, okay, what's your destination port group? We'll just put it on that one. Not using this right now, so we'll go ahead and move it to that. We'll say next, and this gives you the interface. It says, okay, anything in yellow is a new change. I'm going to migrate this VM kernel. This is the IP address, and I'm going to put it in this VM network. You say yes. Task kicks off at the bottom. Give it a second, and there it is. If you ever want to migrate it back, you highlight it, and now migrate lights up, and it'll let you migrate it back to an old vSwitch. Or you can click remove. So that shows you how to create the switch, how to do basic configuration, how to migrate VMs, and migrate your VM kernels if you need to. So that's pretty simple and straightforward. That's probably, going by the blueprint and the fact that you only have a couple of vSphere hosts, about the most you're going to do in the exam. If you're doing this in full-on production, like you want to go do this to 12 or 16 hosts, in the other lesson, I actually walk through how to non-disruptively migrate from a vSwitch to a full-on distributed switch without any downtime. We do it on a host-by-host basis, and then we start using wizards to do a single-shot migration. So to give you a little taste of that, let me go to inventory, because again, time is of the essence in the exam. Networking, choose the switch, choose the host tab. I'm going to right-click and say Add. So we're going to go ahead and move VMNIC 2. He's already part of vSwitch 0, but I can pull him out of that. And it's going to say, okay, you're going to migrate that. Let's see. Now, do you want to do any VM kernels? So let's say I do. I want to go ahead and migrate this one. which is actually a VM service one, but let's say that's a FT VM kernel or iSCSI. You'll just say, yes, I want to migrate it, choose the destination port group. We'll click next, and then do you want to migrate any virtual machines? Sure. So here's the only virtual machine on Megatron. I'll say, do you want to migrate? Yep. Go to there. Done. And next. So in one shot, you can go through and migrate the host using some NICs. Now, you don't want to add all your physical NICs to the distributed switch at once. If you do that, you're going to lose connectivity while it makes that change. So what I do is what I call walking the host over. I'll do 1 or 2 NICs that are redundant in another vSwitch. I don't, if I got a vSwitch 0 with 2 physical NICs, I don't move them both at once. I move one, migrate the VMs, migrate the VM kernels, make sure everything's good. Then I come back using the Manage Physical Network item we saw a minute ago to move the other one. So you don't move the whole thing, you walk it over. So again, if I have 2 vSwitches with 2 physical NICs each, I move one out of each of those over to the switch as an uplink group. Then I go ahead and use the wizard to migrate the VM kernels. I may do them all. I may have VM kernels for iSCSI, for management, for FT. I can move them in one shot, and then I use the wizard to migrate all the VMs. Now, if I was doing this in production, I would probably be creating a whole lot of port groups first. I'd match up my VM port groups, make sure that I had any port groups I needed for the VM kernels. Like if I had a separate VLAN, I would create a vMotion port group and move the VM kernel into that. But once you all map all that out, you can hit finish and it'll just go and it'll just do it. So if I'm doing the VCAP, and if you are not really experienced with the distributed switch, I'm probably going to go a little bit slow. My guess is they're not going to have you do too disruptive, because the problem with this is if you screw this configuration up and you migrate your management VM kernel over and it's incorrect, you can isolate a host because it can no longer talk to vCenter. Hopefully they're not going to have you do that. Hopefully it's going to be things like VM networks and like, secondary vMotion, FT, something like that, VM kernel. So if you do make a mistake, you can recover. I would go very slowly and cautiously. But if you have experience, feel free to use the wizards and kind of do it in a one shot. Again, if you have the Train Signal subscription, go check out the Advanced Networking course, and I break this down in a great bit of detail, but I wouldn't get too caught in the details. So that's it for this lab. Let's jump back to the slide deck. So that's it for this lesson. Now we're going to talk more about the distributed switch. We're going to have a lesson on private VLANs, and we've got one on managing the switch where we'll talk about more in depth how to do some command line changes, how to do some of the other config options that I skipped over. But I wanted to get the basics down, how you deploy, how you do basic configurations, how you do a basic migration out of the way. So this is done. On the next lesson, we'll talk about private VLANs, and I look forward to seeing you on that one.